Okay, so as we further look at trigonometric equations and functions, we're going to start looking at what their graphs are. But before we do that, we're going to think about some ideas that are kind of specific and important towards trigonomic functions. The first one deals with this, and that is we've talked about this before with degrees, but we'll talk about it in terms of radians this time. And that is that if we have the sine of pi over 6, that is going to be the same as the sine of 13 pi over 6. And the reason for that is, right, when we do pi over 6, that's this angle right here, right, because it's pi over 6 around the unit circle that has a radius of 1, so a circumference of 2 pi. And then if we get pi over 6 here, when we go all the way around, right, then we get add 2 pi to pi over 6, and we get 13 pi over 6. And so that's an important idea for us. There's also another part of this that's an important idea, and that is over here, 11 pi over 6 is also, not 11 pi over 6, 5 pi over 6 is also the same for sine. Now, it's not the same for cosine, but it is the same for sine. And so the way that we can write this is the sine of an angle is equal to the sine of that angle plus 2 pi. And these values are always going to be the same when you're talking about sine. And so we call this being a periodic function. Periodic means that it repeats itself. And trigonomic functions are the first periodic functions that we've really run into in algebra. And so the way that we write them algebraically, we say, well, a function is always the same if you add a certain amount, a period, p, to its input. And so for any value, and notice that this is for any value of x. And so for any value of x, if you add this value to it, what we call the period, in the case of sine, 2 pi, the result is the same. And it just is always going to repeat itself. And so this just goes on for infinity, and so it just repeats itself over and over and over and over again every p, which is what we refer to as the period. Okay, and so a period of a function is the value added to the input where the function repeats. What this looks like graphically is, a very basic type of graph would be one that looks like this. And so we could say it would be something like this. Let's just do it really basic. And so this is the graph of your function as a periodic function. And so you can see that the period here, where does it repeat itself? Well, it repeats itself for every x equals 2. And so this value here is the same as this value here, the y value. Remember, when you say the value of the function, what we're really saying is the y value on the graph. That's what the value of the function is. That's the connection between a graph and the value of the function is the y value, right? The y equals the value of the function at that x, right? And so these two are the same at that point, and the distance is 2. And so this would be periodic because it's a repeating graph, right? It just repeats itself over and over again. And the period of that function would be 2. And so graphically, it's actually sometimes easier to see what your period is than it is to see it when you're actually doing your math. Okay, now, so we're going to have these periodic functions. We're going to see that most of our trig functions are going to be periodic, and that's something that we're going to need to pay close attention to. The other thing that's interesting about periodic functions is they have symmetry. Do you see how in this picture, if I fold it along the y-axis, the value would be the same, right? Or if I folded this along the y-axis, it would fold on top of each other. And so we call that being symmetric about the y-axis. And so that symmetric about the y-axis is a common feature of periodic functions. And so what we call that, we have a name specific for that, and the specific name for that, is an even function. And an even function has a graphic definition, a function. So they're going to have two different definitions to this. The first is graphical, a function that is symmetric about the y-axis. Right? So if it's symmetric about the y-axis, meaning if it's on the left side of the y-axis is the same as the right side of the y-axis, we call that an even function. And then it also has an algebraic definition, and that is the even function is if I put in a negative value of x, if I put in the opposite value of x, it gives me the same answer as if I put the positive value of x, right? If I put in 2, that gives me this value out. If I put in negative 2, that puts in this value, right? The positive and negative are the same. Do you see how that kind of tells us, oh yeah, that makes sense that that's symmetric about the y-axis because f of 2 and f of negative 2 are the same. They give you the same value. F of 5 and f of negative 5 give you the same value. So that's your algebraic definition. And so we're going to use this a lot to do that. You might be asking yourself, well, why is this called an even function? The reason it's called an even function is because when you think about polynomials, right, polynomials that are considered even have to have this property about them, where each of the powers of the polynomial have to be even for it to be an even function. Because if I take a look at this, when I plug in f of negative x into this, I get negative x to the fourth plus negative x squared plus 2, but negative x to the fourth is just the same as x to the fourth. Negative x squared is just the same as x squared, and then 2 doesn't change. And so f of x equals this, f of negative x equals that, which is the same. That's why it's an even function. If you throw an odd power in there, f of x equals x cubed plus 2x squared plus x plus 5, that is different than f of negative x, because when you do negative x to the third plus 2 times negative x squared plus negative x plus 5, that equals negative x cubed plus 2x squared minus x plus 5. So even though the 2x squared and the 5 are the same, these are now negative, and so this is not an even function. So that's where the term even function comes from. The other one is called an odd function. And an odd function also has a geometric and or graphical and geometric and an algebraic definition. And so an odd function, well, you might think, oh, it's going to be symmetric about the x-axis. Well, that's not what it is. It turns out that it is either, there's two ways to think about it. One is we say f is symmetric about the origin. But what symmetric about the origin means is it's got rotational symmetry. Meaning if you rotate your graph 180 degrees, which basically means if you take your piece of paper and you turn it over, like just rotate it around and so that the bottom becomes the top and the top becomes the bottom, the graph looks the same. When you do that, what it really means, from a trying to figure out is this actually symmetric, it just means that if you just take a point and rotate it all the way around, it's going to be the same. Which, if you think about what that means graphically, if I've got a point right here where it is x comma y, if I rotate this 180 degrees, what that point turns out to be is negative x comma negative y. So when you change remember over here, what this would have been is that if you had x comma y, if you think about symmetric about the y-axis, it would be negative x comma y. So then x became negative, but the y value stayed the same. In this one, both of the signs change. If the x value sign changes, then the y sign value, the y sign changes as well. And so algebraically, that looks like this. F of negative x, if you put in negative for your x into your function, the result is the opposite of the function. So essentially that negative that is inside here ends up outside on your function. And so again, it's called an odd function for the same reason. If my function is f of x equals x to the fifth plus x cubed plus x, if I plug in negative x into that, I get f of negative x to the fifth plus f of negative x to the third plus negative x, which just equals negative x to the fifth minus x to the third minus x, where each of the terms is the opposite of the other term. And so that's what makes it an odd function. So there's going to be two ways that you're going to be identifying if something's an odd function or an even function. And that's going to be most of what you're doing in this lesson is saying, is this an even function? Is this an odd function? One way of doing it is going to be substituting in, is looking at the graph and saying, does the graph have rotational symmetry? Right? And so the rotational symmetry, if you want to know what that looks like, it would be something like this. Right? Can you imagine if I took this right here and I just took this and rotated it around? If I rotated it all the way around the origin, this part right here would be up here, this part right here would be down there, and they would look the same. And so it has this rotational symmetry. And so yes, it is an odd function because you can rotate it 180 degrees. Or you are going to do this calculation. You're going to do the exact same thing I did here. So let's just do a couple examples doing it like that. And so let's start with one that looks like this. And you want to say, is this even, odd? And you can have neither as an answer. Okay, so is this an even function, an odd function, or neither? So you plug in to do that. Algebraically, all you have to do is plug in negative of your value, and then do the calculation. Well, that just turns out to be x squared over x to the fourth plus 1. F of negative x is the exact same as f of x, and so that this is an even function. Okay, and then we could look at one like this. F of x equals sine of x. Well, if I look at f of negative x, does f of negative x equal sine of negative x? And so now we got to think about, well, what does this mean? Well, in terms of sine, if I have the x value, and so if I look on a coordinate grid, right, and if I remember, I calculate sine, and remember what we talked about yesterday, where sine of x is just going, the sine of the angle is just going to equal the y coordinate. Well, if this is x comma y, over here would be negative x, and for it to be the same, right, it would be, the y values would be the same at negative x, because it'd be negative x comma y as well. And so in this case, this one would be an even function because f of x does equal, because this is going to have the same y value as sine of x and sine of negative x have the same y value, and so they have the same, they're going to be an even function. If I looked at one like this, if I plug in negative x, I get negative x squared plus negative x plus 4. That gives me x squared minus x plus 4. And so this would be a neither. It's neither even nor odd because it's not the same It's also not the opposite, and so it can't be an odd function, and so this would be a neither. And then an odd function, remember when you see an odd function, right, it just has to be the exact opposite. So x to the fifth minus 5x. When you substitute in your negative x, you get negative x to the fifth minus 5 times negative x. And so that gives me negative x to the fifth plus 5x. Well, negative x to the fifth plus 5x, exactly the opposite of x to the fifth minus 5x. And so that is an odd function. And so we can now identify that it is an odd function. So that's even functions and odd functions. They become very important because a lot of trig functions have this quality of either being an even function or an odd function, and we'll get into that more as we start to graph trig functions.